en redes sociales del Instituto Mexicano de Tecnología del Agua. La más cordial bienvenida para todas y todos ustedes para dar inicio a los trabajos de este 10º Congreso Nacional y tercer Congreso Internacional de Riego, Drenaje y Biosistemas. En nombre del Instituto Mexicano de Tecnología del Agua y del Colegio Mexicano de Ingenieros en Irrigación, les damos la más cordial bienvenida y les deseamos que los trabajos que se lleven a cabo de hoy hasta el miércoles del 8 al 10 de diciembre sean del mayor provecho para su desarrollo profesional y para la irrigación en sus respectivos países y espacios donde se desarrollan. Como ustedes saben, en el programa está indicado que el protocolo formal de inauguración se realizará en un par de horas a las 11 de la mañana, hora de México. Sin embargo, comenzamos ya desde este momento con uno de los componentes más importantes, que son las conferencias magistrales que estaremos teniendo a lo largo de este congreso. Y para presentar a nuestro primer conferencista magistral, yo tengo el gusto de saludar y darle la bienvenida en este escenario, en este podium, al doctor Waldo Ojeda Bustamante. Él es el presidente del comité organizador de este 10º Congreso Nacional y tercer Congreso Internacional de Riego, Drenaje y Biosistemas, para que presente a nuestro primer conferencista magistral. Doctor Waldo Ojeda, ¿cómo estás? Muy buenos días. Adelante, por favor.
Okay, now we are going to change in English since Mr. Ravindra Ulangwar, he's in India, no? He's our first keynote speaker. He's a very important person in India, and we are happy to have Mr. Ravindra here. I want to introduce him, his resume. He's mechanical engineering in hand, and also he has a MBA in marketing management from the Symbiotic Institute of Management in India. And something very interesting, also he was a Fulbright scholar in 2009. The Fulbright in the United States is very famous for most people attending in the United States to get a master or high-level studies. It's very important for us because he's involved in for many years, I think, his professional career related with the design, planning, and construction of various and several projects from drinking water and utility water, and especially for irrigation system in water supply, not only for agriculture, but for industries in India and in the international market. This is the top 25 certified international professional engineer. We call him the PE, Practical Engineering in India. Is fellow from the Institute of Engineering in India. Is vice president from the Head and Water Management and global lead for irrigation business for Willow Meter and plant pumps. He's also instrumental in the design and building of one of the world's largest pumping system projects in Surashatra branch canal pumping station for the Sardar Sarovar Narmada Naiwan Ltd in Gujarat, India. It's important because this project provides drinking water for 30 million people and irrigate about 500,000 hectares. The success of this project has transformed the economy of this state, of the state of Gujarat, by watershed management. So it's a pleasure, Professor Ravindra Ulangwar, to have here. And now we are going to have your presentation in the screen. We are connected now. Please, can you put all the presentation?
Yeah, right. Yeah, I'm sharing. Yeah.
So we can now to start this.
Can you see the presentation?
We have aquí tenemos la presentación, ¿no? Okay. I think you had the presentation over there. Can you share?
Yeah.
Okay. The name of the talk is the design, planning, and construction of irrigation system projects in India. Please, okay. Vijay, I don't know if you have the presentation. Can you share it over there? We're waiting for, okay, go, okay. Yeah, we are seeing. Can you put it in the presentation mode?
Yeah.
Yeah, we are now we are watching the presentation. Okay, good. Good. Ready?
Yeah.
So we are ready.
Yeah.
Ready.
You
Thank
are
you.
able to hear me and also can see
Yeah.
my presentation?
We see you. We see you and hear you very well. Go ahead.
Can you hear me clearly?
Yes, we hear you very well.
Yeah. So first of all, thank you very much. Very good morning and warm welcome to all the participants, organizer for the third International Irrigation and Drainage Meeting, organized by COME 2025 and IMTA. So my topic today is design, planning and construction of irrigation project in India. I'm really honored and it's my privilege to be here for such an august gathering. And I'm really thankful to Mr. Waldo Ojedo, President of COME2, Dr. Alberto Gonzalez, the coordinator for IMTA, and also my friend and well-wisher Dr. Vijay Lapshetwar from ICID India, who introduced me to this August gathering. So I'll be taking you through my own experience of designing, planning, and construction of a smart irrigation project in India. Okay, Buenos dies a todos, as an honor, Mr. Equicon Sted Hoy. I just try to speak to you in Mexican language. So wishing you all very good morning. It's my great honor to be here. Okay, just to give you idea to connect, like in the opening session, it was mentioned that by Mexico and India has a lot of similarity. Just to give you idea, how is the Indian account for 18% of a global population. You know, we are the one of the largest populated country, almost 1.4 billion people, 1.4 billion plus, but we have only 4% of water resources, world's water resources. So that you can understand what is the stress on the water resources in India. The highest people, but only 4% of water share of the world resources. The average rainfall in India is about 4,000 billion cubic meter, which is very large. But the issue is we have a lot of water, but the water is available where it is actually more at where it is not needed. So the issue is we need to take the water from one place to other place where it is really needed. So most of the country's rainfall over a 4 months period, June to September, and I just was going through the Mexico's also geography, and I came to know most of the time Mexico also has same period, 3 to 4 months of rainfall. So more or less India and Mexico challenges are same, and this rainfall is very spatial, and also throughout the country we have very uneven distribution of rainfall. I think it is a similar situation in Mexico also. Just to give you idea, India river basin. So here when we talk about irrigation or agriculture, we talk about the river basin and hydrological zone, which normally the water resources are talked about. So these are the various river basin. You can see the map of India. So this just to give you the perspective of how the water are actually, which are the major river basin and how the water resources are distributed throughout the country. So the catchment area is 20,000 square kilometer, and there are 12 river basins, 12 major river basins with a total catchment area of 2.53 million kilometers square. So out of which you can see the yellow part, you can see this, I don't know, can you see my mouse there? So
Yes.
this yellow part is one of the largest river. I think many of you must be knowing. We have one of the largest and holiest river in the country. It's called the Ganga. And this is the Ganga, Brahmaputra, Meghna. This is the largest basin with a catchment area of 1.1 million square kilometer, which is more than 43% of total catchment area in the country. So there are many other rivers which has the catchment area more than 100,000 square kilometer, like Indus, Mahanadi, Godavari, Krishna. So if you see the northern part of the country, which has lot of water, but not the same case in other part. The western part actually is very less water because there are hardly any rivers flowing in the western part. This part, you can say the westernmost, which is the Gujarat, which was mentioned in my also introduction. We did a one big project in Gujarat because there is no water. So the big dam which was constructed on one of the river called Narmada, and there is a big canal network to feed the water to this for irrigation and drinking to this zone, western zone of India. So just to give you idea about the India, so you know the perspective how we are talking. The 46 medium river basin with a catchment area between 2,000 to 20,000 square kilometer. Okay, just we saw the major source in irrigation in India is actually the surface water, which is the river basin. Just now we talked. So if you see the major irrigation surface water, which is in a blue area. So here we have one of the largest rivers flowing in the country. So you can see many blue patches, which is based on the surface water. And then we have minor irrigation, which is shown into the red colors, which is actually basically the groundwater and small reservoirs and the tanks. And the yellow patch, what you can see is the rain-fed crop, rain-fed agriculture. So other area like a forest and natural. So this blue, red and yellow, these are the area of interest. You can see it is very unevenly distributed. And there are a lot of water bodies all across the country. Okay, but at the same time, there are a lot of emerging opportunities in India based on the recent trend. So Indian irrigation system market is poised for remarkable growth because we have 1.4 billion people to feed. At the same time, the Indian economy is totally based on agriculture. We are agro economy, mainly similar to the Mexico. The projected, the CAGR, the compounded annual growth rate is close to 11% during the period, the same period when we are talking 2023 to year 2028. And India is one of the second largest arable land area, encompassing 141 million hectares. And out of which the irrigated crop area is almost 50%, which is 71 million hectares. And there are many government. Actually, in India, the irrigation sector is governed by many government policies from the federal government as well as from the state government. And there are many programs which are driving this irrigation sector, which is all the funds, finance is from the government. So all the big programs which are now currently implemented in India are backed by the government funding. So there is one program, we call it a Prime Minister program, is actually US $7.7 billion in one of the flagship program of the present government. So there is a huge push from the government to develop the irrigation infrastructure in the country. So if you see how the irrigation, in fact, in India is, we are dividing the irrigation projects in a small irrigation. Actually, any project which is less than 500 hectare is called a small irrigation. The medium irrigation projects are between 500 hectare to 2,000 hectare, and the major irrigation are actually close to 10,000 hectare. So any project which is more than 10,000 hectare is called a major irrigation project. So most of the projects which are actually classified as a small, medium, or major based on the command area, that is which is defined in a hectare. So recently in country we have a trend, and there is also government policy which actually we call it a pressurized distribution network. So I think during opening session we mentioned that in Mexico also there are a lot of canal-based projects. Similarly, now the pressurized distribution network where the water is taken from resource to the root of the crop or to the boundary of the farmland through the network of a pipeline. So this is a pressurized water because there is a pumping system, and through pumping we develop a pressure so that enough pressure is available at the farm boundary, and this is also called ready for micro irrigation. So now what is happening? You saw the country which has very uneven water distribution. So there are many areas which has a surplus water and some areas which has deficit water. So government is also putting up a large infrastructure project where they want to transfer the surplus water from one river basin to the river basin which has a less water, so that they can protect this area from the flood. The river basin with a high water resources are prone to the flood. So they can, when they transfer the excess water from one river basin to the other river basin, they protect the area from the flood. At the same time, they make the water available in the other basin where there is a scarcity of water. So the government of India are now launching a many project where they are linking the river basin for transferring excess water from one basin to other basin. And the primary objective of this project are for creating the irrigation resource. So we just mentioned we have two source groundwater base. So normally these are the open well and also the bore well. I think it is a similar situation in Mexico also, because groundwater is, I think there is a lot of exploitation and the water level is very speedily decreasing, and we have more higher capacity pump to draw the water from the long this borewell from the depth of the earth. We have surface water based, mainly all the big projects which we call it a community irrigation projects are based on a surface water, and the source of this water is either the lakes or the dams and the canals and the river. So India during last 75 years have built many dams, and almost I would say all the potential where we can build a dam has been harnessed by government, by the central federal government. Mainly this is the state government subject. So all the states they have developed the dams, and these dams are the primary source of irrigation and also for the drinking water for the communities in the rural part of the country. And also this dam has their own canal network. At the same time, many rivers which has a perennial rivers, we have many large river which we saw in the beginning in the river basin. These are the perennial rivers which flows all the 12 months, are also the source of irrigation, because the many projects, large size projects are built on a river. And one of the case study which I am going to present is also the river based large community based project. In surface water, there are two types. Initially, when India was independent, so initially we started with a gravity irrigation. And once the gravity irrigation, all the command area has been covered, then second phase came with the lift irrigation, where you can see in the picture top, in a large river, they have built a pump house, and there are battery of pumps, number of pumps are installed. These pumps are lifting water from a river, and you can see this rising main, the pipeline. and they're lifting water and taking it to the higher elevation where there is a command area, which normally cannot fade by the gravity. So you need to lift the water from one level to the other level, and then there is a series of pumping. Sometimes it is a one stage, sometimes it is two stage. So we have this project is also I was involved. This is one of the big project in the central part of India, the river called Krishna, and one of the largest pump house when it was constructed 20 years back, one of the largest pump house in Asia, I would say. Okay. So we have either single stage pumping or we have multi-stage pumping. We call it a series pumping. If the command area is very, very high elevation, then we also take one pumping station, take water to the pumping station 2 and then 3 and 4. Likewise, depending on how the command area is distributed at a different level, the water is transferred from one place to other place with the help of pumps in the large pumping station. So last, I would say 10 years, the country is shifting to the system called a pressurized distribution network, along with the SCADA system. SCADA system, all of you are aware. These are the programmable logic controller and also the automation. We call it a SCADA system. So in pressurized distribution network, there are also two types. One is we are lifting water and taking water to the delivery chamber. And from delivery chamber, the water goes to the pipeline network through gravity, and it goes up to the farmland. So it is two-stage pumping, first pumping and taking it to the various delivery chambers, which are located throughout the command area, depending on the topography. The highest point, normally we put the delivery chamber so that all the area below delivery chamber can get enough pressure at the farm boundary. Second system in a pressurized system is direct pumping, in which there is no delivery chamber. The water is taken directly from pumping station through the pipeline network up to the farmland. Up to the 1 hectare is the outlet in a farm boundary, where the farmer can connect either sprinkler irrigation or drip irrigation. These are the two popular micro irrigation systems in India. I believe same with Mexico. Now we don't have a central pivot system yet because the unit farm size in India are normally very small. Farmers farm holding size is hardly 2 hectare or 3 hectare. So it is not feasible to put central pivot system in India. But there is a lot of government program, there are a lot of financial program or financial support given by the government for a farmer to go for either sprinkler system or a drip system. Depends on which is the crop and how is the soil. So, but these are the two most popular micro irrigation system in India. Just to give you idea how big is the Indian market. So we have 141 million hectare of a net cultivatable area, out of which the irrigated area is 71 million hectare. So in fact, I think it is Mexico has 6.5 million hectare, what I know, the irrigated land. So we are 10 times bigger than the Mexico as far as net irrigated area is concerned. And again, it is distributed by groundwater. So almost 43 million hectare is groundwater, and only 28% is covered under micro irrigation. So out of 43 million hectare, 12 million hectare is covered under micro irrigation, and surface water 28 million hectare, and the micro irrigation coverage is very minimal. Actually, it is negligible because this big area groundwater based schemes are all government finance, whereas surface water now just starting in a big way. So slowly farmers now, once the water is available at a farm boundary, the farmer will adopt sprinkler or drip irrigation. So we have the program which is called per drop more crop. That is the motto or tagline of the government program, where they want to harness every drop to generate or to grow more crop. So it is called more per drop, more crop. Okay, now just I mentioned, India is shifting from a canal-based system to the pipe-based system, which according to me is a big revolution in improving the water efficiency, which all of you as irrigation engineers also agree, because here there's no wastage of water. And the biggest problem in India is if you have to put the canal, we have to acquire the land from the farmer, which is on a permanent basis, and which is a big painful process, and it takes long time to get the land from the farmer if you have to lay the canal. And this is the one of the reason many irrigation schemes were not so much effective, because they could not develop the complete canal network in covering the whole command area. There was some gaps, and then the water could not reach to the tail end. So the farmers at the tail end were suffering. And so that is why now, as per government policy, we have to, any project in irrigation project in India by government policy has to be through pipe network. We cannot, new project cannot be with a canal. You know, there are many advantages through pipe, no wastage of water, no theft, no evaporation, and there is an equitable distribution because every farmer up to tail end can get the water, better control and management, no contamination. You can open the, as per the irrigation calendar. There's no maintenance. Canal has a huge maintenance and silting and all this, you know, and the projects are happening very fast. Now it has come down almost 40% time. Earlier we used to take say 5 years, now they take 2 years. And since there is a increased water use efficiency, in the same water, 50% more land can be irrigated. So this is now government policy in India. All projects should be with pipe irrigation. Okay, I think I'll run a little bit fast. Smart. So we call it, when it is a pipe irrigation, it is a smart irrigation because those are with a pumping and a SCADA system. So we know that the benefit of smart irrigation, you all are experts, so you know. But just to touch upon, basically, it is helping farmer to generate more income from more because of higher water use efficiency and agriculture productivity. The yield of the crop has gone up very substantially, which is generating substantial employment in a rural area. Earlier, many people from the rural area, they used to take one crop during the rainy season, and later on they used to migrate to the big cities for earning the money, because there is no water after the rain, so they don't have any work, so they go to city, and then you go, you know, the city is crowded, lot of urbanization and all associated problem. So because now this water is available in the farm for second season and the third season, the reverse migration, we call it a reverse migration. Now these people from a rural area are not going to cities, and they are busy with their own farm. So which is bringing a lot of social benefit, bringing happiness, the community, the family life is gone up, a lot of social issues are resolved. And the other benefit like recharging of the water and global warming. So I'll take you through the success story of one of the state. We call it a Madhya Pradesh. This is an India map you can see. And this state is right in the center in the India. And that is how the Madhya is the center. Madhya is an Indian Hindi name, which Madhya means a center. Pradesh means a region. This is a central region. So this state has a done remarkable work in the development of advanced smart irrigation system using this pipe distribution network, where the water from the river or reservoir through the network of thousands of kilometer pipeline is taken to the farm. So just to give you idea, the state is having different river basin. The biggest river basin is the westernly flowing river called Narmada, one of the largest river. And you can see this yellow river basin. And this water, in fact, state got the quota because this river is flowing through 3 states, and every state has allocated quota of water. If they don't use, then they lose their rights. So they have to leave the water for irrigation within some time, specified time. So far, government did not do anything, but suddenly they realize if they don't use the water, they will lose their control or their rights on this water. So they have come out with many projects, but the problem is that this river is flowing at a very low elevation, and all the command area, all the region is at a higher elevation. So if they have to use this water, they have to put big pumping station to lift the water from river and then take it to the higher elevation. The all command area is situated at a 500, 600 meter from the river basin. So the big size pumping system was required if you have to take this water for irrigation. So just to give you idea, initially I just mentioned they did not do anything with their water. So the cultivatable area was only 0.3 million hectare 20 years back, and now it has reached to 6.5 million hectare. And there are now currently many projects are running, and very soon, within 2 or 3 years, they will reach to 10 million hectare, which is I think more than the area of Mexico, irrigated land of Mexico. There are two departments who is driving this project. One is Water Resources Department, state government, and there is this Narmada Valley Development Authority. They form the special purpose vehicle for using the water resources from this river called Narmada. Okay, so you can see because of this, so many irrigation project state government has invested. So you can see the progress, the agriculture development. We call it transforming the agriculture through irrigation. The state is growing from 4.5% GDP. Now they are growing at 16.5. This is one of the highest in the country. This state is highest growth area and also driven not by industry, but driven by agriculture. So agriculture growth also, you can see it was merely 0.3. It was negligible in 2003. After 20 years, now it is 19%, very, very impressive. Per capita income is more than 10 times. It was $125 only. Now it has gone to $1,600. Irrigation command area has increased 0.7 million hectare to 4.5 million, and it's very fast growing because of various schemes. And you can see agriculture productivity. They used to take 1,195 kg per hectare was the productivity, which has more than doubled. It is now 2,000, close to 2,500 kg per hectare. Similarly, you can see there is an impressive growth in the total food grain production and also sugar cane production. So currently, this state has 125 number of large irrigation projects under various stages. By 2025, very soon this year, by end of this year, actually now it is almost close. So estimated command area is going to be 7 million hectare. And I just mentioned they are working very seriously per drop more crop. So every drop of water they want to use to grow more crop. So what they have done one more marvelous job. They have chain of reservoir, various reservoir available. They call it Amrut reservoir, and they have connected this reservoir, and they are also utilizing this water resources very effectively. And there is one big program. This one project, one single project is close to $1 billion and 0.3 million hectare farmland under single project. So this is the size of the project currently are under operation. So I'll quickly take you through. Okay, how these projects are designed. Now I think this is the interesting part, which I think you are looking forward. So every command area under project is divided into chuck. Chuck is the one unit where the size of the chuck is normally 20 hectare. So what they do is they combine the farm of every farmer and make a unit of a 20 hectare, and it is in a local language, we call it a chuck. And this further subdivided into 4 zones, and each zone is like a sub chuck, which is a 5 hectare. And at a manual on-off wall, they put it at 1 hectare. So 20 hectare divided into 4 zones, 5 hectare, and every 5 hectare divided into 5 1 hectare outlet. And the project is designed in such a way that 20-meter pressure should be available at 1 hectare outlet, which is normally at a farm outlet. And depending on the soil condition and weather condition and the type of crop, we call it a kharif crop. Normally it is a wheat. This area is very, very popular for the high quality of wheat production. So the water, the crop water requirement or the water duty, we call it irrigation duty, is 0.33 liter per second. It varies 0.33 liter per second to 0.35 depending on which zone the project is located in a state. And the complete pipeline is designed in such a way that it delivers 10 times of the irrigation duty. So when we size the diameter of the pipeline, we have to take 10 times the duty. So the irrigation, that is pipeline, is designed for 3.5 LPS per hectare. And all this pipeline is underground and up to 300 mm diameter. We use HDPE pipe, you know, this high density polyurethane, which is grade P100. Then 300 mm to 1000 mm we use ductile iron, which is K9 grade, that is the pressure grade. And above 1000 mm we use the steel pipe with the epoxy coating, which is a food grade quality. Okay, this is how the distribution network I told you. Suppose this is the river. From river the water is taken, and this is the complete pipeline, the hydraulic network of the complete command area where we want to take the water. So for every project, government declared the command area, say 10,000 hectare or 20,000 hectare. We are working today on one project whose command area is 100,000 hectares. So you can understand the size of the scheme is such a big. So normally it is divided into many villages, and depending on village, we have the farm record, land record, and from land record is the basis for designing this project. And depending on the topography, the elevation difference, the pipeline is designed using the various hydraulic software like WaterGem or Autodesk. There are many software popular in India. So all those software were used for deciding the routing of the pipeline, the sizing and the diameter, and how do we reach to the every farm that is up to 1 hectare. So it is like a telescopic network of pipeline, the bigger diameter, and as you go away, it goes on reducing, and then we go up to last, it is normally 60 mm. Sometime it is 3000 meter when you start at the beginning, at the beginning, and the tail end, it goes up to 60 mm or 90 mm, depending on what is the total flow. So any project, if you see, this kind of maps are developed, and we use Google Map for preliminary design of the command area. We call it a command area design or pipe network design. So the Google Map is used. So if the water is too low, I said the water was running at a very low elevation. So first we have to lift the water, pumping station 1, lifting water and putting to pumping station 2, 2 to 3, 3 to 4, like the cascading pumping, series pumping we call it. Once water comes to the height of the command area, and then it goes through the gravity, and then it goes to the different zones. This is how also by schematic. Actually, we have a pumping station at the beginning, and then we have pipeline, and on pipeline we have air management system, because this pipeline is underground and we need to have proper venting of the pipeline. So the air release walls are provided, control walls are provided, isolation walls are provided. And at the end, this is at a 20 hectare, which is called outlet management system. Here the control walls are placed. So I'll just take you through quickly to the control wall. This is how the unit, we call it outlet management system, which is installed at 20 hectare. This is like a box. The pipeline is coming, and since it is 20 hectare, 30 hectare, it is 13.5 liter per second. And this is going to every 5 hectare check. This is the control wall. This control wall is actually operated through hydraulic pressure of the pipeline, and there is solenoid operation, and we use solar energy for operation of solenoid walls. So no pipeline is seen above the ground. Everything is underground. So every time the 3 walls are open as per the irrigation calendar or irrigation scheduling, we call it. And then after this cycle is over, another 3 walls will get open. And these are radio connected. So this wall can be operated remotely from a control station or from mobile or from laptop anywhere in the world. So there is a wireless communication system, very advanced. So every wall, every farm can be controlled remotely using the radio link. So this is, it looks like this. The actual picture you can see, this water is coming from the ground and there is air wall and there is the isolation wall. Here there is again filtration system. So because we want to use the water for sprinkler, it should be clean water. So we filter the water with 200 micron. And here are, you can see the walls, and this is the box in which all the control circuit is mounted. There is a battery. This battery is operated through solar panel. So you don't need any electricity, and the wall also operated through the line pressure. So you don't require any electricity. It is a electricity less and wireless system. And we can control the pressure of the wall by opening the throttling, by controlling the opening and closing of the wall remotely. So this is called a sea wall. And there is a controller and a radio. You can see there is a wireless radio network, which is used for controlling this wall remotely. And there is a web SCADA system, so that in a central control room in the pump house, all these kind of boxes are connected, and you can run the program irrigation schedule depending on what is the crop and what is the season. So complete program can be fed into computer, and it will, the whole system will work automatically. And farmer will get a notification on his mobile if whenever his turn comes, when the water is going to start, 10 minutes before, it gets this SMS on his mobile that your wall water is going to come. So this is how the SCADA screen will look like, where you can see what is the incoming pressure, what is the delta P, what is the outlet pressure. Then wall open is green, wall close is red. So you know which farm, where it is going, his mobile number, what is the area of a chuck, and then all the position, how much wall is open, how much wall is closed, what is the water going, how much total volume delivered today. Everything is available on a quick click of a button. So this you can access anywhere. You know the temperature, what is there, what is the battery life, what is the sunlight. Everything is monitored remotely. How is the network? So this is a very advanced SCADA system which monitors the every node which is installed at 20 hectare. Okay, this is a central control station which has all the pumping system and SCADA system. So you can operate the number of pumps depending on the water level, the complete irrigation demand in the command area. You can decide how many pumps to be operated. Then there is a VFD, so we can operate higher flow, lower flow. Also, the power is also calculated. So energy efficiency is also taken into consideration. So every pumping station has very advanced instrumentation and control to operate a big pump. These are a very big pump, 3 megawatt, 4 megawatt each pump. So normally each project is 50 to 60 megawatt energy we consume. So we have to be very mindful how we use less energy to pump more water, right? So this is how we do the gateway. There is a radio, wireless radio network, complete command area. We install like this, the tower. These are the wireless radio tower, which controls all such OMS installed in nearby area. So depending on the topography, the height of the tower and the location of the tower, we decide. And there is a LoRaWAN. These are different technology, you know. Sometimes we use the GPRS, which is a mobile network. Sometimes we use the LoRaWAN, which is another communication radio, wireless radio technology. And all these towers are talking to the remote server, which is on the anywhere in the world, and then it gets connected to the control room. So sitting in control room, you can give command to any outlet to close the wall, open the wall, and what is the demand in the water. If there is a rainfall, we can close all the wall. Okay, this is how I think you are more expert. I will not talk more on the sprinkler irrigation. There are a lot of advantage of sprinkler irrigation because the field is evenly wetted, so uniform plant growth is possible. Okay, this is earlier system of flow irrigation. I think I will not touch because you all are expert. Okay, I will just take you quickly through one of the project. This is the Nagalwadi project. I think I'll finish in 5 minutes. Okay. Here the same Narmada River. This project is lifting 54,000 meter cube per hour. Total pipeline length is 60 kilometers. From here, water is lifted and we are bringing water to here. So this is a 60 kilometer long. Total height is 293 meter. The total project is 110 million USD and 106 villages are getting benefited. Total command area is 47,000 and total power is almost 78 megawatt and we are consuming 52 megawatt to run the pumps. So this is how the water is coming from a river and the command area is all at a different elevation. So what we are doing is we are taking water in pumping station 1 to 2, 2 to 3. 3 is feeding water to this command area. Balance water is going to pumping station 4. From 4, there is another command area which is fed at 10,000 hectare. There is another command area of 5,000 hectare. The balance water goes to pumping station 5. So there is another command area. And similarly, likewise, we are lifting water in 7 pumping station. And along the length, we are going to feed the water to the command area alongside the pipeline. Okay, below is my company where I work. Is a joint venture involved in this project with one of the large civil construction company who was responsible for construction civil work and laying the pipeline. We did all the automation, we did all the pumping system, we did all the electrical work for this project, and we supplied 36 large pump. Each pump is 3 megawatt. This project is very successful. You can see we supplied 36 pump. Total head is we are lifting water by 819 meter, 15,000 liter per second. There are 7 pumping station. There are 11 rising main, 36 pumps, and total power is 77 megawatt. You can see different pump, and each pump is 3.6 megawatt. Huge machines, huge machines. Okay, these are the just photograph to give you idea. Pumping station 1, which is lifting water from. This is from the delivery side. The river is on other side, back side. So this inside there are pump, and you can see there are 5 pumps, 4 working and 1 standby pump, which is lifting water and then putting it to the pumping station 2. These are the big pump. You can see large motor at 3 megawatt inside the pump house. This is another battery of pump in the pumping station 3. This is how the pumping station is looking like, where we are taking. Here you can see only this intermediate pumping station. So you have to manage. This is the only storage of water. So we have to synchronize the operation of pumping station 1 and 2. Otherwise, what will happen? If there is an uneven operation, the flow rate is not balanced, water will spill over, or this pump will not get enough water. So we have to very carefully plan and control the number of pumps so that same water, what is coming pumping station 1, same water goes to pumping station 2 and then 3. This is another very different pumping station. You can see very special semicircular 4-bay. You can see this electrical control system in a same compound. We have similar the control room here. The control station is installed here. Central control station which controls all the operation of the command area. Here you can see actually since the water is taken from river, there a lot of sand is coming. So what we have done is we have installed online filtration system. The battery of filter, you can see all these are cluster of filters, and all whatever the water is coming from a river through pump is passing through this filter, and they're passing they are filtering to 500 microns. So whatever water is going to the command area is filtered water. You can see here the depth of the pump house, because the water level in the river is varying almost 30 meters. So we have to design a pumping station suitable for different water level. After the monsoon, the water is at highest level. And as we go from monsoon to the summer area, the summer season, the water level is depleting and then it goes to low level. So very long pumps are installed inside. And this is also one interesting system, the bladder vessel, because if the pumps are running and suddenly there is electricity failure, all the water which is traveling with high pressures will come back and it will create a big impact, pressure rise, and sometime it may lead to failure of pipeline. So to protect the pipeline from such transient condition, this is called a bladder vessel, which work as a shock absorber. So any shocks because of the transient condition are absorbed in this bladder vessel. So every pump house, this bladder vessel, so this is a highly engineered and very specialized system which protect.
Por ahí, Alberto, si quieres, voy a hacer para preguntas, no comentas que
Hola Alberto.
vamos a una reunión con ellos, posteriormente.
Hola Alberto, ¿nos escuchas?
Una más, ¿no? Y le mando un mensajito, ¿no? De que vamos a tener una reunión con ellos, todo el seguimiento, es una parte bien interesante. Bueno, tenemos nuestro...
Aló Alberto. Hola, hola.
Sí, sí.
Hola, ¿nos escuchan? Alberto. Alberto. Hola Alberto. Coordinador, por favor.
We lost connection. We lost connection, and we are almost out of time. So
Yeah, I am finishing the last slide.
You give us your last 5 minutes. And later, I think we can have another meeting with you and all from the IMTA and the COMET, our association, in to get a better, more information. We can exchange experience what we are doing. So please, and we don't have time for questions. We are out of time. So can you make the conclusion for this, please? Thank you.
Yeah. So just to conclude, can you hear me?
Yes, we hear you.
Yeah. So actually, this project was successful because there were a lot of social engineering was done. We involved the farmer in making the project successful. They were explained how the project is going to work, and they were made a stakeholder in the project. So a lot of meeting happened at a village level to explain to the farmer during the construction and after the operation. So there was a social engineering and which led to the farmer empowerment. So the impact of this project is there is a substantial increase in the command area from which was close to 15,000, which led to 47,000. The improved water use efficiency, it actually from say 30%, it led to the close to 80%. So 5,000 hectare area is irrigated with 1 million meter cube of water as against the average of 210. Wheat crop production is increased almost by 3 times. Farmers have started taking not only 1 but 2 but 3 crops in a year. And as I mentioned, there is a good positive social impact, reverse migration from cities to the village. And actually, it brought the complete socio-economic upliftment to the region. So I just finished my part. Hello. Hello.
Yeah, hello. Can you hear me? Yeah.
Yeah. I finished my presentation.
Yeah. Thank you a lot for participating. I think we need to follow the connection. It was a pleasure. We don't have no time for questions, but we are going to follow with another maybe Teams meeting so we can exchange experience in what you are doing in India and what we plan to do in Mexico. Will be very helpful. So thank you, Facundo, Mr. Facundo over there, Bidai, and Professor Ravindra for your talk. I hope we can in the next time we can have more time and we can change more experience. Thank you very well. Nice to meet you, and we thanks a lot. Bye bye.
Thank you so much for giving us an opportunity. What I will do is I will share the presentation to also Dr. Vijay Lapshitwar and also to Facundo. And I request Facundo to be in touch with you so we can work more closely. And I invite, if you are visiting India, please let us know. It will be our pleasure to show you the project site. We can go to the field.
Thank you very much. Thank you, and again. So now we are going to send you also our diploma. We prepare a diploma. We send you by a digital form. So thank you. It was signed by our general director from the IMTA for me as president of the committee. Thank you Thank you.
Thank you so much. Thank you
for the opportunity.
Gracias. Saludos. Dale. Ok, bueno, vamos a pasar ahora. ¿Quieres pasar? Sí.